Hi brief calculus students, I got asked this question from the chapter 2 review, which is basically exponential regression. So I can bring up the calculator like I would with linear regression. So I need to know the input and the output. So it looks like the function says input is t, which was hours. So soon would probably be 0 hours, then after 3. Alright, so stat, edit. Let me go ahead and clear out L1 and L2. So 0 and 3 hours. Okay, at 0 we're looking at 280 milligrams. At 3 hours, only 35 milligrams remain. Alright, so we've got our 2 points, 280, 35. Stat, calc. We don't do linear regression this time. We're coming down to number, well, 0 or 10, whichever you want to think of it. So I could have hit 0 down here, but I didn't know exactly which one. And this is the reason I'm looking through, because I know there's at least A and B. But here's exponential regression at 0. I hit enter. It's asking me if I want something besides L1 and L2. I really don't. But here is an exponential regression. So that will be 280 times 0.5. And I come over here to this little button. It says sup. Anyway, it's superscript. That's what it means. And t is the variable. See, when it's an exponential function, that means the function, the variable, is in the exponent. Right there. So, yep, it likes it. So use your model to find the amount of aspirin in the bloodstream after 6 hours. I think that might already be, yep. I tried to video this before, had to redo it. So I changed my window. Let's see, we only need to come down. We were interested in knowing about find exponential after t hours. Oh, here we go. After 6 hours. Well, I don't want to leave 6 as the max because I kind of need to have it on the graph. Went up to 280. Let me change my scale to, I don't know, 10. Alright, graph. Whew, exponential decay. And here we go. Now, there are 2 ways I can find the answer from the calculator without really doing a lot of work. Second calc, number 1 value at 6. Second calc 1 6. There we go. Enter. That looks like 4.375. Alright, go. Second table 1, 2, 3, 4, 5, 6, and there it is. Again, 4.375. I don't see any limits on significant figures, so I'll just go ahead and put the whole thing in 4.375. Okay, that's what you need to do.